What if the driest place on Earth held an invisible ocean? Imagine an endless supply of fresh water floating right above your head. This isn't science fiction anymore. We are officially weaponizing condensation physics. We are learning to bypass the hydrological cycle entirely. This new approach allows us to synthesize liquid life directly from thin air. We are no longer limited by where rivers flow or where rain falls. The very air around us, even in the most parched deserts, is becoming our most valuable resource. We have unlocked a fundamental secret of nature. This knowledge is changing everything we thought we knew about survival. This is changing where human life can thrive. This technology represents a monumental shift in our relationship with the planet. For centuries, civilizations have been built around water sources. We followed rivers settled near lakes and prayed for rain. By 2026, we won't just be surviving in the desert, we will be terraforming it. We are transforming these arid landscapes into lush, tropical oases. What was once seen as barren and empty is now viewed as an opportunity. It is a canvas for a new kind of city, a new way of living. The world's major aquifers, the vast underground reservoirs of fresh water, are reaching critical depletion levels. Visual: show split-screen infographic. Healthy aquifer in past versus nearly depleted aquifer 2026 with red warning signs. As aquifers shrink, the ground above them can sink, damaging buildings' infrastructure. Coastal aquifers become contaminated with salt water. The infrastructure that carries water to our cities is aging and breaking down. A single break in a critical pipeline can leave millions of people without water. For cities in arid regions, this reliance on distant water sources is an unacceptable risk. The focus is moving away from finding and transporting water to synthesizing it locally. At its heart, harvesting water from the air is not a new idea. Nature has been doing it for millennia. It is the simple physics of condensation. Warm air can hold more water vapor than cold air. When the temperature of the air drops to a certain point, called the dew point, it becomes saturated. Our atmospheric water generators are essentially dew-making machines, optimized for performance and efficiency. Instead of one brute force cooling surface, modern systems use an advanced cooling gradient, allowing efficient harvest even at just 15% relative humidity. To further boost efficiency, especially in low humidity environments, we pair cooling gradients with another class of materials, desiccants. In our systems, a desiccant acts like a molecular sponge. The material passively pulls water vapor out of the air. A small amount of heat does this. The water is released as a concentrated, humid vapor. The most advanced systems now utilize solid-state molecular sieves, or a metal-organic framework. This happens passively, without any moving parts, no fans, no compressors, which is why it's completely silent. To release the water, a small electrical charge is applied directly to the material, and the trapped water molecules are released. The real breakthrough is the synergy with localized solar power. A modest solar array on the roof of a building can generate more than enough power to run a unit that supplies the daily water needs for a family. This synergy solves the energy-water nexus that plagues desalination. We are no longer burning fossil fuels to solve our water problem. Instead, we are using the most abundant energy source in the desert, sunlight, to harvest the most needed resource, water. This creates a virtuous cycle. It is the physics of synthesis powered by the physics of the sun. Section 1. The Water Mesh Network. We are moving away from a centralized hub-and-spoke system. Instead, we are building a decentralized water mesh network. Imagine a city where every neighborhood, every apartment building, every home has the ability to generate its own water. The water is produced at the point of consumption, immune to regional droughts, safe from cross-border political disputes, far less vulnerable to sabotage or cyber attacks. One of the most significant advantages of this decentralized approach is the reduction of our ecological impact on coastal environments. The most damaging byproduct of desalination is the brine. This super-salty, chemical-laden wastewater is pumped back into the ocean. The high salinity and lack of oxygen kill marine organisms. Coral reefs' decentralized atmospheric water generation completely avoids this problem. There is no brine, no toxic discharge. Along with the water, they pull in countless small marine organisms, including plankton, fish eggs, and larvae. By moving away from massive coastal plants, we are decoupling our water security from ocean industrialization. Section 3. Hydroponic rings and microclimates. These are circular, multi-level vertical farms. They circulate nutrient-rich water to grow produce year-round in the city. Funnel it into misters, fogging systems. The evaporation causes evaporative cooling. Section 4. The green lungs of the city. They combat the urban heat island effect. We're introducing tropical flora into previously inhospitable desert environments. The key to maintaining these new green lungs and hydroponic rings is automation. Soil moisture sensors, humidity detectors, temperature gauges. This is not the old wasteful sprinkler system on a timer. This is precision irrigation. We're not just turning the desert green, we're giving it a nervous system. A smart, responsive landscape that thrives, powered by water pulled from thin air. The mastery of atmospheric chemistry is doing more than just solving a water crisis. It is fundamentally rewriting the map of human civilization. We are witnessing a great decoupling of real estate value from natural geography. These regions, blessed with abundant solar energy, are transforming into vibrant technology hubs. Entrepreneurs, scientists, pioneers, they are flocking to these new boomtowns. The old maps are becoming obsolete. Former wasteland borders are no longer static lines on a map. They are dynamic frontiers of expansion. This transformative technology, like all powerful tools, comes with its own set of challenges and responsibilities. If we can build anywhere, we must be careful not to consume landscapes indiscriminately. We risk creating a world of water apartheid where the rich live in lush green enclaves while the poor are left to suffer with the failing infrastructure of the past. The challenge for planners and policymakers is to ensure that this life-giving technology is deployed equitably. This means implementing smart land use policies that encourage dense, sustainable development while protecting wilderness. We stand at a pivotal moment in history. The convergence of crises, aquifer depletion, failing infrastructure, climate change. This is a call to action for the planners and architects who design our cities. You are no longer limited by pipelines. Your new resource is the sky itself. This is a call to action for the investors and entrepreneurs who fuel innovation. This is your chance to invest in the very chemistry of survival. Finally, this is a call to action for communities and individuals everywhere. The future of water is no longer in the hands of distant authorities alone. It is in your hands. The journey from a barren desert to a tropical oasis begins with a single drop of water condensed from the air. Together, we can turn that drop into an ocean of opportunity, transforming our world for the better, one neighborhood at a time. The future is not something we wait for. It is something we build.